Right, welcome back everyone. Today we're going to be talking about projectile motion. So this is the first of many videos for projectile motion. I still don't know how many I'm going to do because there's quite a bit to explain on projectile motions. So in this video specifically, we're going to see how the maximum distance travel, time in air, time to get to the highest point on the trajectory, and the maximum height are derived and how to obtain them. So let's begin with a case where you have your plane, and then let's just say soccer ball. That looks more like a basketball, but again, I'm not an artist, so just give me some slack, please. So you have a soccer ball, and somebody comes along and kicks it, and it gives the ball an initial speed of v naught at angle theta. So notice how this is parallel to the ground, so I can just call this theta at angle theta relative to the ground, because you can just draw any parallel lines to it and the angle will be the same by geometry. So angle theta and velocity v naught, and you're asked to prove how to find the maximum distance travel, time in the air, and maximum height. So let me write that down. So we're going to be finding the time to the highest point, time it took to the highest point. We're also going to find the total time traveled. We're going to find the maximal distance traveled, and also the maximum height. Maximum height reached. All right, so I'll just give you the formulas before we even begin, and you'll see later on that is how we actually get. So for the time on the highest point, that formula ends up being v naught times the sine of theta over gravity. For the total time traveled, well, whatever goes up must come down, so you're just going to multiply this sine theta over g. Now, these formulas only apply for when your, in this case, object, which is a ball, ends up on the same plane field. If you have a cliff, that's different, which is in our future videos, so we're just assuming that it ends up in the same level right now. So maximum distance traveled. So the maximum distance traveled, that is going to be v naught squared times sine of 2 theta over g, and the maximum height obtained is going to be v naught squared sine theta squared over 2g. Now we're going to derive those formulas real quick, so keep them in mind. We will come back and make sure we did them well. Now, I'm going to move upward instead of downward like usual. Changing up things a little bit. Exciting. So now, all right, let's start working out with the time that it took to get to the highest point. So now, remember how this is going to have to be broken down into its vectors because it's a 2-dimension and we cannot work with 2-dimension vectors. So the x portion, I'm going to change colors. So the x portion is going to be, and from our previous videos, we know that that's going to be v naught cosine theta. And for y, this is going to be v naught sine theta. All right. Now, using kinematics from our previous videos, we know the formulas, which I'll put them up again, just in case. So it's going to be x equals to x naught plus v naught t plus 1 over 2 at squared, and v equals to v naught plus at. Those are the two we're mostly going to use in this video to prove these equations. So now the time for the highest point, we have two options. We can use x, but we don't know the distance. That's a different problem. So we're probably going to use the second one. So let's go ahead and use that for our first derivation. So for our first derivation, we're going to say v equals to v naught plus at. Now, there's something special about the highest point of any object's trajectory, and that is that the velocity is going to be 0. So the highest point of any object, the velocity is 0 over the y-axis. So we're working over the y-axis to clarify here. Now, we're going to say, okay, well, at the highest point, this will go to 0. And now I can find my time. Now rearrange the equations, because this will be 0 equals to v naught y plus at. Recalling from our last video, this ends up being negative v naught y over a equals to t. Now remember, acceleration on Earth is negative gravity, so the negatives cancel out, and your t ends up being v naught y over g. Now what is v naught y? Well, that's just the y component of our v naught, and that is v naught sine theta over g. Exactly what we gave over here. All right, now for the total distance traveled, whatever goes up to the highest point must come down to the highest point. So you're just going to multiply this times 2 for the total time, and that is what we have right here. All right, now moving on to maximum distance traveled in a different color. Now, recall from maximum distance travel, let's use the first one because we already know time, which will be our total time. If we use x equals to x naught plus v naught t plus 1 over 2 at squared, there is no acceleration over the x-axis. There's only acceleration acting over the y, which is gravity. So this goes to 0, and your initial position, let's call this where it starts 0, and wherever it ends x. So this goes away as well. So you end up having x equals to v naught t. Now, we know our v naught, and this v naught is over the x-axis. So let's go ahead and put it, v naught t over the x is just the x component. So v naught cosine theta times our total time, because that's the maximum distance traveled, which is up and down once it hit the ground again. So now the total distance traveled is 2 v naught times sine theta over g. Now notice how the v squared and v naught give you v naught squared. And now I just want to point out something, an assumption that I'm going to make and skip this step. Sine of cosine times the sine of theta, 2 sine of theta to be more precise, using trigonometry will give you sine 2 theta. And that's just one of those rules that you don't need to know. So I'm just cutting it out for you and just saying you're going to have to believe me on this one. And you can do the search if you will like. And then the g just carries over, and we're going to say over g. And now notice how that is what we have right here. And now for our last one, the maximum height. For the maximum height, that is at the highest point again. So we're going to use our first equation, except we're going to change it for the y-axis. So we're going to say y equals to y naught plus v naught y over the y times t plus 1 over 2 at squared. Now, remember here this changes because of gravity, acceleration. So this ends up being negative 1 over 2 gt squared. All right, so now our y initial was the ground as well, which remember we always say that ground is 0, so this goes away. Our y final, that's what we're trying to find. Our v naught initial, our v initial over the y, we said it was v naught sine theta. So let's go ahead and put that. V naught sine theta, and I forgot to put time right there. All right, now times your time, which it's only one way because it's the highest point, the maximum height. So then that would be v naught sine theta over g plus, actually, it's minus 1 over 2 g t squared. Now t, remember the time that it takes to go only up. So that would be v naught sine theta over g squared. Now, doing FOIL method, we end up having v naught squared, v naught, and v naught squared times sine of theta squared over g minus 1 over 2 v naught squared sine of theta squared g right there times g over g squared. So now this g cancels out one of the two g's on the bottom. And now we are left with v naught squared times sine of theta squared over g minus 1/2 v naught squared sine theta squared over g. Now they're the same thing except for the negative 1/2. So now to make them same common denominator, or if you just want to think about it as 1 minus 1/2 gives you 1/2, or if you want to do it the old-fashioned way, put a 2 and a 2, this ends up giving you 1/2 v naught squared sine theta squared all over g. And that is the same formula that we have right here. So I hope this video was helpful. I know it's tedious and you may not even know or care why you would need to know this, but sometimes professor asks you to prove these in exams, and I just wanted to help you guys out with that. So in the next video we will be actually plugging in numbers and just using the formulas that we derived in this video, which are right here, and you'll see how it works out and how beneficial it is to know just those 4 formulas and projectile motions. So remember, like us on Facebook, subscribe on YouTube, and I hope you guys have a great day.